Hey everybody, this is Miss Fred. I'm going to be teaching you how to do transformation on parent graphs. That's what this lesson's on. So you've gone through most of, not all of them, but most of the parent functions that we do in pre-calculus, and now we're going to start moving them around. You did this in Math 3, so I'm going to be using all the different functions that you worked with in the past. So these are notes. Make sure you are taking notes and then upload them to Edpuzzle, or if it's not Edpuzzle, just straight into the Google Classroom from the video. Okay, here we go, parent graphs. And transformation. Okay, you're gonna put your name in pen. Some of you guys I noticed started putting in pencil. Please put it in pen. All right, here is the general form that you need to know how to do transformation on these. So you have your function, you have an A term, and then I'm going to put these bars here, but what they really mean is any function that you're dealing with, not just even absolute value. Okay, so I'm actually making it really big so you understand this is a general case of what you're going to be doing. So it could be even the square function like quadratic, or even the square root. And here's your little n for the polynomial, and then finally k. And we'll be deciphering what all these things mean. And I'll write it specifically for the function you're working with so you recognize the form better. All right, we're going to talk about what these things do to the graph. What do these things do to the graph? If you have a number, and in my case the number is h, and it's attached to the x's, your transformation or translation is going to move along the x's. So in other words, if it's moving along the x's, you're going to be horizontal. Left or right. So these are all directional words that we use when we're talking about this. Left to right. Then the k value tells us to go vertical. So you're going up and down. And if k is positive, then you go up. And if k is negative, you go down. I'll go back and make sure I explain this sign better as we go through the exercises. The a value, which is right here, tells us if the graph is going to be skinny or fatter across the y-axis. So across the y-axis. So if I have a y-axis here, and I'm going to use the square root function because you guys know that really, really well. Here is my parent graph right here, kind of. And then this would be a skinnier graph. And then of course you would have your really, really fat graphs. Okay, so I know that that's not, perfect, but you have the idea of how the a value works in the exercise. Okay, so what is b? So b may be a new, I'm going to do that here in yellow. So that might be newer for you. So the b is the skinnier or fatter across the x-axis. So we call that a compression, but I'm just going to put it in just regular language. So it's skinnier or fatter across the x-axis. And that, hopefully that makes a little bit of sense because again, the b is attached to the x expression. So that's how the formula works. So stop the video right now and make sure you understand how all of these symbols are related. Okay, we're going to move on now to your first example. I'm actually going to start with one of the more complicated ones, because it's just good for you to have practice in how these work. So I'm going to use the parent function f of x is equal to 1 over x. Now, as you know, I keep coming back to this one over and over and over again. And that is because, like I said, it's a little complicated and I want to make sure you've seen it many times. But we will look at other problems too today. So I'm going to put the parent function in black, and you always start out by asking yourself, hey, where are those points for the parent function? Well, if you remember from the other videos, you substituted in x in for -2 into the function and so on, and you ended up with these values. Remember, 0 is undefined, and then we have positive 0.5. Then you come over here and you start graphing. Now here's the thing. I am not going to graph the parent function all the way. I'm just going to leave these dots here. I am going to put in the asymptotes. Okay, so that's part of the parent function. Okay, and the asymptotes have little arrows on them also because they represent invisible lines. But what I really want to do is start doing the transformation on these graphs. So what I'm going to ask you to do now is graph the function g of x with 3 over x. So the difference between these two graphs is the numerator went from 1 to 3. So that's the difference. Now I already have my parent graph there, so now I can just build off of it. And what this is it is the stretch. So I will go ahead and write that equation out. So in that transformation form that we just looked at. And I'm leaving the b out of this one on purpose just for simplicity reasons so it doesn't get too confusing. The other thing I want you to notice is there is no h in this one and there is no k in this one. So really what you have is you have that stretch that's right here. So that's the stretch. That's that a value again in the equation. So what am I going to do? Well, what you do is you come over here and you multiply all the y values by 3. All the y values by 3. So that's what I'm going to do. So I'm going to write 3 all the way down. Okay, this is still undefined because, you know, it's undefined. And then I'm going to plug in or substitute in my values that are the y. And then just calculate like normal. And then we're coming over here to do the transformation. Well, the good news is we don't have any moving horizontal or vertical, so that's great. So that means we don't change the asymptotes. The asymptotes stay the same. But the point values start to change. So I'm going to just go ahead and take my points and start graphing them. And you need to stop the video if you're not seeing where the points are coming from. Okay, stop the video. A lot of people are saying, well, I can't learn from the video sometimes. Some of you are doing great with the video. I just heard from a student, well, I'm having a hard time doing the video. And I said, are you stopping the video? And the student said, no, they're just rushing to copy it. And I said, the point of the video is that you can stop and go back and rewatch things. And then the student said, oh, that makes sense. And then I said, oh, I'm glad that that makes sense, because otherwise, you know, then the video isn't really doing anything for you. And just to really hone in on that idea that the asymptote isn't different, I'm going to put in this asymptote to represent the new graph. You don't have to do this. And then I'm going to connect my points. And that is our new graph. So that was our first transformation for this year. So I'm going to just get rid of these so you can in fact see that that is the first transformation. All right, we're on number 2. We're going to stick with that parent graph, 1 over x. And this time I want to do a horizontal and vertical shift. So I'm going to leave the stretch out of it this time. So let's do this guy right here. So the general form, just to remind you back, and this is kind of a stripped down form of the general form, looks like this from the previous video. It's not letting me do that. I better move over just a little bit. So 1 over x minus h, and then the fraction is what gives us the parent graph, and then I left out the b on purpose again. So I'm just reminding you what's going on. If you look at the example this time, there is no a because the top number here on the function is 1. So we don't have a stretch. So we don't even have to worry about that, but we do have to worry about the parent function points. And I'm just going to go through and do those really fast because you're good at those too now. Okay, undefined, right? If you plug 0 in here, you'll get 0 in the denominator. It becomes undefined. And then, so that's my parent graph. I'm going to just plot those points. Stop the video if you need to look at the graph in more detail. Okay, my asymptotes are part of the parent graph. I said that before. And now we need to look at the transformation. Okay, so we're going to start with the horizontal. And I just want to touch base with you on the horizontal about what's going on with the formula. So I'm just going to write this portion of the formula. This is not an equation. This is just an expression inside the equation. Now, when you first inspect this, it looks like h is negative, but in fact, it's not negative. You need to start thinking about these functions with the negatives on the x's in this manner. So that's part of the formula right there. So let me put that in other color so I can emphasize that. This is part of the formula. So if I go down here, it's part of the formula. And when you see it attached to the h, you now see that the h is actually a positive number. And so you need to start thinking about the situation as plus h. So this means that when you look at either one of these, your graph is going to move to the right. Your graph is moving to the right. Okay, you definitely need to pause the video and take a look at that. So we're now going to move all the parent points to the right. So let's see here. So I've now taken care of the points going 3 to the right. So I'm just gonna take these out so you don't get confused. But what I wanna share with you right now is that we have an asymptote that also needs to move 3 to the right. So this asymptote right here, this vertical one, is gonna move 3 to the right. So now we no longer have to worry about this asymptote. And that is our shift 3 to the right for everything on the graph. Now finally, I'm going to have to move all of the values up 1 to follow this function that we're graphing. So I'm going to move the points up 1. And now that I've done that, I will get rid of the green ones. It's fine if these are on your paper. I'm just doing it so it's clear in the video. And then finally, I need to move up that asymptote up 1. So I'm going to do that. And erase the old asymptote right here. So I hope you can now see that our new graph has shifted over and gone up. And then you can, of course, connect those points. And the arrows should be, the ends of the graph should be getting pretty close to the asymptotes, because they tell us how the graph is behaving. And then there you go. That is the shift that you need. Well, now we're going to put all of this together. So we've got, from the previous example, we have a 3 on top, and we're now going to put all the elements in one graph. Whew! All right, a lot going on here. So this is 3. And then my new graph, we're gonna put all this together, is 3 over x minus 3 and then plus 1. Okay, start out with that parent graph. Now I'm reminding you how this works. I'm reminding you that you have a 3 on top right here. So this is going to be your stretch. And what that tells us to do is take all the y values and multiply them by 3. So that's exactly what I'm going to do. And we've done this before in this same exact video. And I'm going to erase this part because remember it's undefined regardless. And then I'm going to come over here and graph those points. So with the stretch, I'm graphing the points, which I'll do in blue. So you may ask me, well, why didn't you do the parent graph this time? I'm not doing it because what's going to happen is the stretch is going to act like your point of reference. And so I just don't want the graph to look, getting too congested. And then I'm putting those asymptotes in just to emphasize that they are there. And I'm not going to connect the points because that is not the graph I'm being asked to end with. So make sure that you understand that. So what I'm now asked to do is to do the horizontal shift, which is attached to the x's. So remember, the formula says x minus, okay, right? X minus, which makes this positive 3. So you're going to go right 3. And then to remind you, you're going to go up 1. So I'll just do the purple part first, so things just stay real clear. So I'm going to do the horizontal first. Okay, now I have to move. I have to move the asymptote also over 3, just like the last example that we did. So I'm going to move it 1, 2, 3. And I'm going to get rid of the asymptote we no longer need. All right, and then finally, we're going to take everything and move it up 1. Which means I'm also going to move this asymptote up 1. So I'm moving that asymptote up 1. It's a little hard to see, so I'm going to go ahead and put it a little black here. Okay, so stop that video. So I no longer need this blue asymptote, which is from the stretch part of the graph. And I just lost one of my points, so I better put it back in. Let's see, where does that point go? So that goes up 1. Okay, I'm going to now get rid of the purple dots. And I'm going to double check and make sure my points are in the right spot. 1, 2, 3, they are. And now I will do the final graph, which is this right here. Remember, you are making sure the graph is hugging those asymptotes without crossing. And there you go. We did some graphs on rational functions, and I hope you're understanding it.